Hello student, we have come to the last chapter 10.5 of this topic. Alright, for today we'll be looking at applications of conduction, convection and radiation that we see in our daily life. Okay, for the very first slide, we'll be looking at the application of conduction. Okay, in this slide you can see that there are three examples of three such applications: frying pans, woolen clothing and double glazed window. Okay, the very first one, frying pan, I'm quite sure all of us are familiar with it, or definitely you have come across it. Alright, so the metal base of a frying pan is a good conductor of heat. Okay, we all know that metal. So what it does is that it allows heat energy to be transferred quickly, okay, from the heat source, which is the fire, alright, to the food so that the food can be cooked easily. Okay, but at the same time, in order to hold the frying pan, it must have a handle, right? And of course, the handle cannot be made of metal, right? So what you see in this picture or in your textbook is a wooden handle. Right? Sometimes it can be made of plastic, those that doesn't melt easily. So of course, wooden, plastic, they are non-metal, and obviously they are poor conductor of heat. And this is very obvious, right? Because our hands do not want to get burnt, okay, when we are using the frying pan, right? This is because heat energy is not conducted easily, right, to the handle of the through the handle to our hands. Okay, this part is pretty straightforward. Then we go to the next application, woolen clothing. Okay, all right. So let's make it very clear first. Air is a poor conductor of heat. Poor conductor of heat. So it also means that it's a good insulator of heat. Okay. Now, what it means is that there are porous material such as wool, cotton, all this material. Okay, what they do is that they trap pockets of air. Okay, making them excellent, good insulator. Okay, you can see in the diagram in the middle here. Okay, this one is to show you in detail. Okay, so this is under our, this is where our skin is, right, inside, our body, and this is the piece of wooden clothing, right, this part, okay. So the air is trapped inside here. Okay, the air is trapped inside or within the woolen layers. Okay, so from here, the clothes that are made from wool keep us warm. Okay, heat from our body is not conducted away easily. Okay, so the heat is trapped because of the air, right? So our body heat does not get released and therefore keep our body warm. Okay, this is where this is important. Okay, especially when the outside or the air outside is cold. So imagine winter now in the northern hemisphere. Okay, so people wear not just one clothing, right? They wear multiple, right, to trap more air. Okay, that being said, Singapore, we are basically a hot country, so usually we don't wear thick clothes for that reason. Alright, the last example under application of conduction is the double glazed window. I'm not sure how many of you have seen it, or maybe it's not even commonly used. Okay, let me just go through it anyway. So what you mean by double glazed window is when there are two layers of glass panel. You can see in the picture here, there are two layers, and in between the layer there is air trap. Okay, so what does this do? Okay, they use this to reduce heat loss, okay, through the window, right? So how this happens is that a layer of air that is trapped between the glass panel form a insulating layer. So heat doesn't conduct through air easily. Okay, so heat that's inside the building, all right, or heat that's from outside the building cannot get in or out so easily. All right, that is for our first slide. Hope you understand quite easily. See you in the next slide. So in this next slide, we are now looking at the applications of convection. And for our this slide, I'm only looking at two such applications that you are actually quite familiar with. But more importantly, to highlight the understanding of how convection works. Okay, it's nothing new. I'm just going to highlight a few main points here. Okay, let's look at air conditioner first. Air conditioner first. All right, the first thing you must remember or understand is that warm air, okay, which is less dense, will rise up and collect under the ceiling. It means inside the room, warm air tends to be on the upper part of the ceiling. Okay, so when you on the aircon, okay, when you on the aircon, what happens is that the air conditioner will cool the warm air. Right, that means warm air will be taken in by the air conditioner and then releases the cool air. So what happens? So when the air is cooled, it becomes denser, right? And it will sink down to the bottom of the room. Right? If you stand below an aircon, you can feel this air movement, right? The cool air will actually be blown down. So let me just run through the paragraph here. An aircon is used to cool down the air in the room, right? We all do that, especially in Singapore. All right. So where is it being put or placed? It's actually placed at the top, right, of the room. Of us are very familiar with this. Okay. Now, the thing to take note is that aircon uses a lot of energy while cooling the air, while taking out the heat in the air. It needs a lot of energy to do that. So here, what I'm saying is that while you are using the aircon at home, please close the windows and the doors. Okay, this is in a way try to conserve electrical energy. Okay, so this is just to highlight how important it is to save energy. Okay, but I mean understanding is that denser fluid, which is a gas or liquid, will always rise up, and cooler gas or liquid will sink. Right, and in that process, convection will take place. Okay, we look at another example now. Kettle. So what you know is that there is always a heating element that is placed at the bottom of a kettle. Okay, why? Let's go through the 2 points here. Okay, the water at the bottom of the kettle will get heated up, right, as you on the kettle. Okay, as the water is heated up, what happens to the density? The density decreases, right? Okay, I hope you still remember in the other chapter where I explained how convection occurs. Okay, I hope you have seen the video. Okay, where the man uses actually shows convection current using the potassium permanganate crystal. Right, that should be a very uh, easy and clear video. So when the water density decreases, the heated water rises up, right? You can see here with the red arrow. Okay, this is hot water, less dense, it rises up. So water, let's look at next box. Water, the cooler water, the cooler water that is at the top will sink, right? Okay, as it sinks down, Okay, as it sinks down, you can see here. Now it gets heated up, okay, because it has gone down where the heating element is, okay. So with this, a convection current is set up right now. Hot water rises up, the cooler water sinks. So this convection continues until eventually all the water in the kettle gets boiled. Okay, so these two example is quite common. Hope that is not confusing. All right, remember it's all about density, right? Warm or hot air or gas or liquid will always rise up. The cooler, denser air, gas, liquid, water will sink. Okay, see you in the next slide. Okay, we are still continuing on the part of convection, but take note, this is not an application. These slides they are explaining what is sea breeze and land breeze. It's not an application, it's more of a natural effect due to convection. Okay, so let me just quickly run through these two parts. Okay, first one is called sea breeze. Sea breeze. Okay, now before that, let me just draw a human standing on this part of the picture. Okay, so let's go through the points here. Okay, during the day, the land heats up more easily. Okay, land here is of course a solid. Okay, so hopefully you understand that in the daytime, solid will get heats up faster. So the sun heats up the land. What happened then is that it then warms up the air above it. Okay, you can see here, that's what it means. Okay, so what happens when the air is being heated up? Warmer air is less dense and rises. Okay, back to this same old understanding. Okay, when air, which is a gas, absorbs heat, it expands, density decreases, so the air rises. So you can see here, next point, the cooler air that is above the sea, right, move in to replace the air above the land. You can see the arrow here. So there is a movement of cooler air towards the land. Okay, this movement is then called a sea breeze. Okay, why did I draw a man here? Okay, you can see if you are standing there, where is the direction of the air moving or wind blowing? It's blowing from the sea, right? Okay, so that's how you should remember this meaning. Sea breeze means the wind or the air is coming from the sea. And why this occur is based on the idea of what I just mentioned. Of in the daytime, what happened to the air movement between the land and the sea. Okay, if you still don't really get it, just go and look. Let us go through the next one called the land breeze. Land breeze only occur at night. Okay, at night. Just to highlight. Okay. Okay. The point now is to start with is that the sea retains heat better than the land at night. So the sea has retained more heat. So if you continue the same understanding, the layer of air above the sea is the one that gets warmer, okay, because it has retained more heat, or not more heat, but it retains the heat longer. So with that, the air above it gets warmer. Then what happen to the density? It gets less dense, right? The warm air gets less dense, and now this warm air rises. Okay, now it's rising up above from the sea. Okay, you can see from the arrow here. Similarly, on the other side, the air above the land is actually cooler. And what happens is that this cooler air will then move towards, okay, move out into the sea to replace the warm air above the sea that has rise up. Okay, so again, because of this movement of the warm air up and the cooler air from the land towards the sea, we will then set up this sea breeze. Okay, this convection that we call sea breeze. Oh, sorry, my apology, land breeze, land breeze. Okay, same thing. If you draw a man standing in the part here, you will feel that the air or wind blowing from the land side out towards sea. Okay, so this is a natural effect, not an application of convection. Okay, but I hope that let you understand how convection is uh, able to make us know what is a sea breeze and a land breeze. All right, okay, see you in the next slide. Hello, student. We have come to the final application, okay, which is actually the application of radiation that we use in our daily life. Okay, in our daily life. Okay, I think some of this you should be quite familiar or you have actually come across it. Okay, but before I really start, I want to link to earlier part of this topic, okay, where I explain about radiation. Okay, more exact would be the factors affecting radiation. In fact, we're looking at mainly the third factor. Can you recall? Remember the factor that is important here? The third factor. Okay, anyway, if you know the answer, I also can't hear you. So let me just share the factor here. Okay, it's the type of surface. Okay, type of surface will affect how radiation occur or the rate of radiation. Okay, type of surface actually is understood as two parts: the texture of the surface and the color of the surface. Okay, you can see in the few examples here. Okay, it's quite obvious. Okay, but let me just go through this in a bit of detail. Okay, and before we move on, this is what I'm talking about. Okay, under chapter 10.4, where I got this experiment, white can and a black can. Okay, for emission and absorption. Okay, let's delve into the actual uh, meaning here. Okay, so one of the examples or application is about buildings and clothing. Okay, so country like Singapore, we are in the tropic where we actually are quite sunny and hot. You notice that most houses, they are usually painted white. Why? Okay, think about, is it emission or is it absorption of radiation? Same thing. If we are not going to get too hot while going out and it's a bright hot day, what type of clothes will you wear? Okay, of course I know people like to wear black or dark color clothes because it looks more fashionable, but in understanding of radiation, you will normally wear lighter colors, isn't it? White, yellow. Okay, and the reason is, okay, I already given you explanation here, is to reduce the absorption of radiation from the sun, so you don't feel so hot or you don't feel too hot too fast or too quickly. So this is the first application. Okay, the second application is on cooling fins. Okay, so cooling fins here, usually find them inside a car radiator. Of course, when you on the car, the engine is running, it produces a lot of heat. It's bad for the engine, so you want to design in such a way that we release or give out the heat away from the engine as fast as much as possible. So we have this design called the cooling fins. Okay, or it's not only found in the car radiator, it's also found in the refrigerator. Okay, and they are usually dull black in color. Okay, black is the color, dull is the texture, okay, meaning are they smooth or are they rough, right? So black, what do you remember? Okay, what do you remember in the experiment that you have seen earlier? Okay, black is a good emitter right of radiation. So we want the heat to be released or given off as fast as much as possible. So that's why this application uses black color, dull surfaces. Okay, go to the next application, which we just talk about in convection, isn't it? But in this case, it's not what's inside, okay, but it's what is on the outside. Okay, the surfaces, the kettles and pots. You will see that any kettles and pots that you find at your home or your house, they are all highly polished. Okay. Any reason for doing that? Okay, the answer is all there. Okay, because all these are being used to cook right now or to boil right now, or they will be where a lot of heat is inside the pots and the kettles and even the teapot. And usually we do not want the heat to be released or given out too quickly. Right? So this silver color or highly polished surfaces, what they do is that they have to keep the content inside warm for a longer time. So your hot water will not get cooled down too fast. Okay, because silver or highly polished surfaces are poor emitter. Okay, poor emitter. So the heat is being kept longer inside. Okay, that is the third application. And go to the final application, which I think is not uh, seen commonly okay, it's only used when there's emergency. Okay, you can see there's a lady here, right? I think I'm not sure what's the scenario, but most likely she was caught in an accident. Okay, so what happens is that the rescuer will use a special blanket, okay, which is actually shiny surfaces, and right away here you can see that this shining surface acts as a poor emitters of radiation. Okay, and this is to help the people to stay warm by reducing heat loss from their body. Okay, so in an emergency, this person could be already uh, been out in the so-called environment for some time, and the person is injured, no food, hungry, and the surrounding can be very cold. So you want the person not to lose heat further from his body. So this emergency blanket outside is silver or shiny will then be a poor emitter. So it does not allow the heat from your body to radiate or to come out or emit out uh, even more. Okay, so where is this used or where is this emergency blanket being applied? Okay, in the case of marathoners, mountaineers, and even victims of accident, which I just said, right? Okay, so again, this is tying up with the factors affecting radiation, the third factors in particular. Okay, remember that. Hello students, we have come to the last slide, okay, on the application of radiation. Okay, this application is quite useful because it actually shows you all three types of methods of radiation, how to prevent or reduce the transfer of radiation. Okay, so let's go through the rest of the slide now. Okay, you can see right at the beginning here, this is actually a vacuum flask, or some people call it a thermal flask. Okay, before I delve into the rest of the detail given, let's concentrate on this part here. Okay, So a lot of us tend to put hot water inside this vacuum flask and then to keep the water inside warm for a longer period of time. But do you know that the opposite is true? That while it keep hot substance hot, it also keep cold substance cold for a longer period of time. Okay, so if you pour ice water inside, the ice water will stay cold also for a longer period of time. Okay, think about that. Think about that. Okay. Okay, let's run through. Okay, like I said earlier on. Okay, right at the top here. Okay, a thermal or vacuum flask is designed to reduce heat transfer. Okay, using all the three methods: conduction, convection, and radiation. So this must be really a very good design right now by the person who first came up with it. Okay, let's run through the 5 points here. Okay, how it does it. First point, reducing rate of heat loss by conduction. Okay, heat loss by conduction. Okay, so what it does is that, what is this part here? It's actually a insulated cap right now. Okay, and it is, it's an insulated cap. So you can start thinking, or you can start recalling the one that you have at home, what type of material this is made of. Okay, that is the crucial part. Is it metal or non-metal? Okay, so this is where it will help to reduce the rate of heat loss by conduction. Conduction. Okay, all right. So I would like to move on to the next point here. I just want to continue with conduction. Okay, so another part of the design which helps to prevent heat loss by conduction. Okay, now do you ever wonder why is it called vacuum flask? Of course, when it's called a thermal flask, then this word vacuum is not being mentioned, so it may may not have been highlighted. So where is there? You mean there is a vacuum inside this design? Yes, certainly. Look at the diagram. Look at the diagram below while I run through this. There is a vacuum that has been so-called designed in between the walls inside the vacuum flask. Okay, there is vacuum here in between these two walls. Okay, of course you can't really see it because it's inside. So what we realize that conduction, and in fact even convection cannot take place in a vacuum. So there's no way heat can travel from the hot water through the glass wall, okay, or through the glass wall, then pass through the vacuum. No way. So all the conduction can do is up to the glass wall inside. It will not go across. Okay? It will not go across. Okay, take note of that. So this is an important design. Okay, where conduction and convection is being stopped. Actually, no conduction and convection occurs across the vacuum. But since I had this glass wall thing, let me just proceed with the next point below. Okay, now if you actually have a chance to see inside, if you have a chance, you notice that in between the glass wall, okay, the inside, the outside glass wall is actually painted silver. It's actually shiny. Why? Why would they want to paint it silver or shiny? Okay, as the heading here say already, remember, color of the material will affect radiation. In this case, if it's silver surface, what type of radiation will it have? Will it be a good radiator? Will it be a good emitter? Or will it be a poor emitter? Okay, so take note of that, right? Because it will reflect and reduce heat loss by radiation. So this is linked to just now the slide that before this slide. Okay. Okay, I move towards the other side now. Okay, 2 more points. Okay, coming back to the part here, it says that this part reduces the rate of heat loss by conduction. Okay, similarly to the cap that is on top, at the bottom of the flask, you have to have a support, isn't it? Okay, you have to have a support. It cannot be floating inside the cap. Okay, the water cannot be floating. So there has to be a support to allow the water to be rest, the whole container to be rested. So it is actually an insulated support. Okay, insulated means it's definitely a non-metal. So the whole reason is that this allowed to reduce the rate of heat loss by conduction. I mean, this is a quite obvious application or right quite obvious design. Okay, the last one, and up to now I only been talking about conduction and radiation, right? How to prevent or reduce the heat loss by these two methods. The last method actually is back to the cap. Okay, the cap is to close the vacuum flask right now. So when you close it, is there anywhere hot air, or sorry, in this case, the hot water will heat up the air that is above it, and then this hot air will rise up or not? Once you close the cap, will you be able to escape and continue to allow more heated air to or hot air to rise up? Of course, the answer is no, right? So by doing that, you actually cut off any chance of convection current occurring. So this allowed the hot liquid or hot water to keep its heat longer inside the thermoflask. Okay, so this particular design of a vacuum flask or thermoflask is a very good one because it addresses or it actually look at all these three methods to reduce heat radiation by these three methods. Okay, I hope by now, after looking through all the slides, you have a better understanding of how heat has a lot of effects and how it can be used in our daily life. Okay, please go through the video below in the video section and have some fun with the quiz question. Okay, take care. Bye.